All right, so our first lesson we're going to look at is in Chapter 1. Okay, it's the only lesson we're going to do in Chapter 1. And it's more a review of something that's very important we talk about in algebra quite a bit, which is square roots. Okay, square roots are going to come up a little bit this week, quite a bit next week. So I just want to make sure we kind of remember how to work with those. And a good formula for doing something with square roots, kind of where square roots come up naturally, is the distance formula. So the distance formula basically gives you a way to find out how far apart 2 points are. It's probably something you did in Algebra 1, you probably did it in geometry, maybe reviewed it in Algebra 2. So this is probably at least the third or fourth time you've hopefully seen this. Great, so I'm going to call my 2 points that I want to find the distance between points A and B. And A has an x and a y coordinate, and so does B. What I've done to just make it generic is I'm calling A my first x and first y coordinate, and B my second x and second y coordinate. And what I'm going to do is draw a picture of that so we can try to visualize finding the distance between those 2 points. Okay, so there's our 2 points. They don't have to be in the first quadrant. I just did it that way. All right, so my goal here is to find out the distance from A to B. And what I'm going to do is I'm going to turn that line segment into one side of a certain shape. Anyone have an idea what shape I'm going to draw here? And that's going to be one side of it. Yeah, Ryan?
Is it going to be a triangle?
Yeah, we're going to turn that into a triangle. Okay, and the way we're going to do it is we're going to draw a dotted line, or whatever kind of line you want, horizontal right through A. And then I'm going to draw a vertical line going through B. Okay, so here's my triangle right here. Now again, that's not just any triangle. What kind of triangle is that?
Right.
Yeah, it's a right triangle. Okay, so what I'm going to do, just so I have a little bit of room to work, is I'm going to take this triangle and I'm going to make a copy of it off to the side. So that's A, and that's B. So my goal, again, find out how far apart A and B are. Well, we can find the distance from A to that point pretty easily, okay, because they line up horizontally. If I wanted to find the distance between this point and this point, would it have something to do with the x coordinates or something to do with the y coordinates? Yeah, it has something to do with the x. They have the same y coordinate. They're at the same height. Okay? When you want to find height, that has to do with the y coordinate. And all you're doing is looking for left to right. You're using x coordinates. And it's perfectly horizontal. So if you want to find out how far apart two things are, what operation do you use? If you have two values and you want to know how far apart they are. How about Peter?
Subtraction.
Yeah, we have to subtract. So all we have to do is subtract this x coordinate from that x coordinate. Haley, what is this x coordinate? Well, A is the name of the coordinate, but what's the actual x value of A? And what specifically is our x value?
You want the number.
For coordinate A, what is its x value? And it's not going to be a number, but we have a way we represented it. Not sure? Anyone help her out? How about Eric? What's the x value of coordinate A? Well, how did we so the x value is the first part of the coordinate, right? Zach? Sorry. Did you have a brother, Zach?
No.
No? I had another Zach last year. Sorry. Ryan?
Is it just going to be x1?
Yeah, it's just x1. That's the x value of coordinate A, just like y1 is the y value of coordinate A. It's not a number because we don't know it, but we represented it as x1. All right, now, what's the x value of that point that I just highlighted? It's not labeled, but we should be able to figure it out based on other things that are labeled. How about Paige? Yeah, that's x2. How do I know it's x2? Because it lines up vertically with another point. Any points that line up vertically have the same x coordinate. Points that line up horizontally, like A and that one I just highlighted, have the same y coordinate. So if I want to know how far apart those two red dots are, all I have to do is subtract their x values. You could do x2 minus x1 or x1 minus x2. It doesn't really matter. I'm going to do it the way I'm going to show you in the formula in a second, which is x2 minus x1. That's the distance from there to there. Now, I'm going to put that dot there. And I want to find the distance between the dot that's right at the right angle and B. Right, so is it Erie? Erie. All right. How would I find the vertical distance between that point and that point? Perfect. y2 minus y1. Whatever that number is, say it was 10. Say that number was 0. If I wanted to know how far apart they are, just subtract them. y2 minus y1. So I'm just going to squeeze that in over here. y2 minus y1. And that's the distance from here to there. Okay, so now we know those two sides, but what we really want is the longer side in the triangle. Connor, what's that longer side called? Hypotenuse, good. And do you remember a formula from geometry that if you know two sides of a triangle, you can find the hypotenuse?
A squared equals B squared equals C squared.
Yeah, what's that? Perfect. A squared plus B squared equals C squared. Pythagorean theorem. Except I'm not calling the bottom side A, I'm calling it x2 minus x1. That's A. I'm not calling the height B, I'm calling it y2 minus y1. So all you have to do is plug in the two things I circled, or the two things I circled over here, and that gives you the distance formula. So let's plug it in. So we've got x2 minus x1, and you have to square it. We've got b, we're going to plug in y2 minus y1. And you have to square it. And then the last thing is that's equal to c squared. So c is what I want to know. But I don't want to know c squared. Does anybody remember how you can get rid of squaring something so that it's just c? Yeah, Rudy? Yep.
Square root.
Yeah, we're going to take the square root. And that's the final version of our formula. And some people say, well, can't you cancel the square root and the square? No, not if there's addition there. If you have addition or subtraction inside the root, you can't cancel anything out. Right, so we square each side, add them up, and then take the square root. Okay, so the distance formula is basically just your Pythagorean theorem. So if you forget it, you could go back and do this every time, but it's a lot easier to just remember the formula, and then you don't have to do that again. Okay, so let's find the distance between those 2 points. Okay, we'll do this one together, and then I'll let you guys try one on your own. So one thing you might want to do if you're not sure what's going to go where is just label these 4 numbers. Which one is which in terms of that formula. When you start to label them, you've got a couple choices. But once you label this first one, then everything else is automatic. Okay, so Robin, can you tell me what could I label the 4 as?
X1.
Perfect, we could do x1. And now that we've labeled that as x1, everything else is automatic. That has to be y1. Okay, we also could have labeled 4 as x2. Could have, and it would come out the same. Okay, but we called it x1, y1, x2, y2. All right, so Alex, can you tell me, let me just make this a little smaller, how I would start off finding the distance? What would be in my first set of parentheses?
3 minus 4.
Perfect. 3 minus 4.
Squared.
Yeah.
Plus 2 minus 5 squared.
Yep. And now we just have to simplify that out. Now, I said the order you do them in doesn't matter. You might be like, well, doesn't it make a difference if you do 3 minus 4 or 4 minus 3? It does, but then what are you going to do next that it wouldn't matter after that? Before you square root. How come 3 minus 4 or 4 minus 3? It doesn't matter which way you do it. Just do it consistently all the time.
You square the result.
You're going to square the result. If you take 3 minus 4, that's negative 1. If you take 4 minus 3, that's positive 1. If you square each of the numbers I just said, it comes out the same. Okay. So we're going to get square root of 3 minus 4 is negative 1. Squared is 1. 2 minus 5 is negative 3. And Becca, if we square negative 3, we get 9. Perfect. And unless they ask for a decimal, we can just leave the answer like that. Square root of 10. Okay. Any questions on that? Okay. Okay, so take a minute or two and try that one on your own. Okay, same idea. There is going to be something extra we have to do at the end, but if you can at least get to the step that I just did, that's good enough. If you know what you have to do at the end from algebra, go ahead and do it. If not, I'll show you what you got to do. All right, so let's take a look. Okay, I'm going to assume that people were okay, at least getting to the step we did in the last problem. So how many people got square root of 20? Okay, so if you got square root of 20, then you're on the right track. So I'm going to do 4 minus 2, which is 2 squared. I'm going to do 10 minus 6, which gives me 4 squared, and then I get the square root of 4 plus 16, or square root of 20. But square root of 20 is not the final answer. Anyone know what we have to do with that? And this is one of two things we always have to do with square roots. Yep.
Do you break it down into the factors?
Yeah, we've got to reduce that. Okay, so there's many ways you can do it. Some people make a factor tree. Some people break it down into something like this. I try to factor it so that one of the numbers is a perfect square. Okay, so I try to rewrite the number 20 so I can take the square root of one of the factors that I pick. I wouldn't write it as 10 and 2, my method, because I can't take the square root of 10 and I can't take the square root of 2. But I can take the square root of 4. And that would be the final answer. Okay, so anytime you get a square root, you have to reduce it, and you can reduce it using any method that you know how to use.
The way that Ms. Stigner told us last year, which I find pretty easy, you just like use the factor tree.
Yep.
And whenever you have like two of the same number, it just kind of bumps out.
Yep, you look for like a pair.
Yeah.
Yep. So if you want to do it as a factor tree, that's fine. If you can, whatever method you use, it's fine with me. So I just mentioned this. In the last problem, we had to simplify square root of 20. So if you want to do it as a factor tree, that's fine. If you want to use my method, that's the 2 steps that I used. You have to factor the number under the root. That's called the radicand. So that it is the product of 2 numbers, like 4 and 5. And one of the numbers has to be a perfect square. Okay, so perfect squares are numbers like 4, 9, 16, 25, 36, things like that. And then once you factor it that way, you break it apart into 2 roots, like I just did. I had a square root of 4 and a square root of 5. There's my 2 roots. And then I simplified the one that I could. Square root of 4 is 2. Okay, so we don't have to do square root of 20 again. We just did that one. We'll do a different one. Okay, does everyone have the 2 steps? Okay. Or again, factor tree, if that's how you do it. You can do it that way as well. Can anybody think how to do that one using the method I just showed you? Break it apart into something times something. And you want one of the numbers that you tell me to be a number you can take the square root of in your head. Yep.
Could you do 12 and 4?
Yep. You could do 12 and 4. And the square root of 4 you can get is 2. Any thoughts on leaving your answer like that? 2 square roots of 12.
It could probably be broken down more.
It can be broken down more. How can you break down 12? You could do 6 and 2, or if you're going to do a factor tree, or someone else said 4 and 3. Yep. And then you get square root of 4 is 2 again. And what would you end up with? 4 square roots of 3. Now, if you have to do this twice, like we just did, then that means there was probably, bless you, a better way to break up square root 48. Because there's always a way to do every problem in just one step, rather than having to do it twice. Does anybody see a different way you can break up 48? So we only have to do it once. Cameron? 16 times 3, yes. If you notice that you can break it into 16 times 3, and the square root of 16 is 4, you get exactly the same answer, you're just done in a lot less steps. Okay, it's not wrong, especially when the numbers get big, to do it in multiple steps. Sometimes that's the only way you can figure it out. But there is always a way to do every problem in one step, just like that. Okay, any questions on that? Okay. So the last thing we're going to look at is a little different formula. It's called the midpoint formula. This formula doesn't really have anything to do with square roots, but it's also in section 1.1, so just for the sake of covering the whole section, and it's a pretty easy formula, we'll do it. So the notation uses, it's the same idea. You have two coordinates. Coordinate A has an x and a y value, and so does coordinate B. Okay, in a real problem, those will all be numbers, the x1, the x2, and so on. But the midpoint formula doesn't tell you how far apart the points are. It tells you where the middle of the 2 points is. Okay, so if you've got 2 points, what's right in the middle? And the formula I've put up here, there's not really a big explanation to go through like the distance formula, but hopefully it makes sense. You're adding up 2 numbers and then dividing by 2. Anybody remember what that's called? If you take 2 numbers, add them up, and divide by 2, it gives you the what of the 2 numbers? Think if you took like 50 plus 60 and divide by 2, it gives me 55. What's 55 compared to 50 and 60? It's in the middle, but it's the average. Yeah, it's the average of the 2 numbers. So that's all that the midpoint formula is doing. It's taking the 2 x values, adding them up and dividing by 2. It's averaging them. It's taking the 2 y values, adding them up and dividing by 2. Something that people get wrong on a test sometimes. Here it's x1 plus x2. Here it's minus. So make sure you keep the distance formula straight with the midpoint formula. Very simple formula, but if you do minus instead of plus in this one, you get it wrong. Okay, so try that one. I don't think we really need to go through one first. See if you can find the midpoint between those 2 coordinates. Looks like most people were just about there. So let's take a look. So when we find the midpoint, okay, if you don't remember the formula, just think of it as you're trying to find what's in the middle. You're going to average your x's, average your y's. So take 3 plus 7, divided by 2. That'll give you your average for the x. And do the same thing for the y's. Now, if they don't say to leave it as a fraction, you could do a fraction, you could do a decimal. It doesn't matter. So how about Connor? What do I get for my x value in the final answer? Yep, you get 10 divided by 2, which is 5. And how about Heather for the y value in my final answer? Yeah, we get 17 over 2, which you could write as a decimal, 8.5, or just leave it like that. So that thing that I just circled, what is that called? It's the midpoint, which is an example of a in general, anything that looks like this is it's a coordinate. So the difference between the distance formula and the midpoint formula, distance formula gives you a number. Midpoint formula gives you a location. Okay? All right. Okay, so that's it for first section. Okay, so for homework on page 7, 15 to 21 odd, those are some distance problems. 39 to 43 odd, those are midpoint. And then there's a couple square roots here to try to simplify. Okay, so make sure you copy down square root 40, square root 28, square root 108, square root 1440. Okay, so we'll take a look at that tomorrow. And you've got a little under 10 minutes left. Okay, so please use the time to try to get started on something. Okay, if you do have any questions, let me know. And also as part of the homework, bring back the syllabus sheet. Okay, signed.